Okay, this is my third take on this. Hopefully this one works. Here's a graph of a polynomial function. Use what you know about end behavior and zeros to write a possible equation for the function. So we'll start with the zeros. We know the zeros at -2, -0.5, 1, and 3. Okay, so those are our zeros, our x-intercepts. Now we know that we can move backwards x-intercepts, and x-intercepts are related to our factors. We know that x equals 3 must be related to the factor of x minus 3. Because if we set x minus 3 equal to 0, add 3 to both sides, we get x equal to 3. So this is really just moving backwards from when we had factors and found the zeros. Now if you have the zeros, you find the factors. So that would mean that the 0 of x equals 1 came from the factor x minus 1. We're going to skip over the -0.5 for a second and talk about x minus 2. That should have come from a factor of x plus 2, right? But now we've got this -0.5. You could write x plus 0.5, but we usually write factors with integers only, not decimals, not fractions. So I'm going to turn that into a fraction because that's going to help me see what parts there are to this number. So -0.5 is the same thing as -1/2. And then that means that that's coming from a factor of 2x plus 1. Because if you set 2x plus 1 equal to 0, subtract 1 from both sides, and then divide both sides by 2, you get x equals -1/2. So you can see that the factor 2x plus 1 is really, that way we can write that we can get this 0, but from a factor which only has integers. Now I'm going to write this in factored form then. X plus 2 times 2x plus 1 times x minus 1 times x minus 3. And then we need to look at the end behavior. If this was positive, because if you put this in the calculator, x plus 2, 2x plus 1, x minus 1, and x minus 3, put it in the calculator. I'm going to choose a viewing window that's very similar to this one. -5 to 5 for my x's, -10 to 20 for my y's. Maybe that needs to actually go up to 30 because that's a little bit above 20, right? And then I'm going to graph this. Let's see what happens with this graph. Okay, notice what happens. It hit in the right places on the x-axis, but it went in the opposite direction. The end behavior is opposite. So we know that positive in front is what makes these go up on both sides. So if we put a negative in front here, and let's try that. And notice I'm going to insert a negative in front of there. Right? And now graphing it, it left the zeros in the same place, right? -2, -0.5, 1, and 3. But now it turned it upside down, right? So it's this negative in front. So you can use your graphing calculator to check your answer to see if you're getting this right. But that's the best expression for that polynomial function. And then the last one, consider this polynomial function. We're supposed to evaluate at this. So remember, this notation just means plug 3 in for x, plug -7 in for x, plug -1/2 in for x, plug 1/4 in for x. So I'm going to do a couple of those. 12 times 3 to the 4th minus 7 times 3 to the 3rd minus 79 times 3 squared minus 28 times 3 and plus 12. Now notice I put the 3 in parentheses every time I put it in. That's not necessary every time, but it's good practice, and I'll tell you in the next example I do, it'll make sense. So I'm hitting enter, and that means this is a 0, right? I mean, so when I put 3 in for g of x, I get 0. So g of 3 equals 0. And then we'll talk about what that means down here. Now I want to do the same thing. I want to take what I just entered, but this time I'm going to skip to the -1/2 part. I'm going to enter in -1/2 here, and then it really matters that it's in parentheses because we want the calculator to understand that the negative is part of the number and not just not something that happens after you do the exponent. So negative, and then I'm inserting 1/2, right? So I'm inserting 1/2 for each of these. So you can retype this out if you'd rather. I find it easier to insert the -1/2 back over the thing I already typed out. -1/2 plus 12. So now it says the same thing, but I put in -1/2 for everything, right? And notice I just used division, my division symbol for my fraction bar, because -1/2 is the same thing as -1 divided by 2. So hitting enter. So g of -1/2 equals 7.875. Okay, so I'm going to leave these two for you to do, but I want to talk about what those answers imply. So given your answer to A, name at least 2 zeros for this function. Okay, so that means, so if I get a 0 out when I put a number in, that means that's crossing the x-axis, right? That's crossing the x-axis at 3, and that means it's a 0. So I know that 3 is a 0. And because I got a 0 out when I put this in, and that would be where it crossed the x-axis. So moving on to C, given your answer to B, write at least 2 factors for g of x. So knowing that 3 is a 0, I know that x minus 3 is a factor for g of x. X minus 3 is a factor for g of x. Now notice it said at least 2 zeros, so you can, I know that -1/2 is not. So you need to plug these two in, and one of these two is going to be the other 0. And so you're going to have another factor to write for that.